Hi, I'm David. I'm an engineer at Docker. I work out of San Francisco, so technically I should be asleep right now. So you just have to pardon me if I actually don't look like I'm fully alert. So Laura just gave us a wonderful presentation on the RAF quorum. So and my takeaway from it is that the managers, the quorum is a tricky thing. Don't let bad things happen to them. So, and that kind of sort of leads to this presentation. How do you actually manage infrastructure in this world of containers now? Now that we all have this great thing called the container orchestrator, that with that also comes new responsibilities and new challenges. So what are some of the problems that we're trying to solve at Docker? And I'd like to get into that today. So containers are great. You know, they're like little servers. I mean, that run on some servers, that run on other servers. So it's kind of like this situation here. We kind of have like this nesting thing. So that leads to the obligatory slide on the inception. We need to go a little deeper. So let's get into the actual infrastructure itself. So now once we start digging deeper into the infrastructure, we start looking at what's actually powering the entire container platform that you're using, whether it's Docker or Kubernetes. Specifically now we're lowering down to the layer where we're starting looking at the network, the infrastructure itself, the servers, the OS images, and all the stuff that needs to be in place so that you can have a container orchestrator like Kubernetes or Docker Swarm running in the first place. And how do you go about managing them? So you can say, well, but my favorite container orchestration platform already does a whole bunch of stuff. I mean, you know, that's why we have stuff like CNM, CNI, Docker volume plugins, Kubernetes volume plugins, PVCs, and some of the new standards that are coming on. But again, a lot of these all deal with how do you take physical infrastructure resources and turn them into a form that is consumable by your container applications. So fundamentally, all this technology that the container orchestrator is depending on still relies on the underlying infrastructure. And with that, actually gives us from an operations standpoint, a lot more challenges. Because now we not only have to worry about, we come from the world where we're worried about deploying a set of applications as possibly tarballs to a bunch of to a cluster of machines. Now we also had to worry about quorums. We had to worry about volume drivers, plugins, network plugins, a whole bunch of other things. So with that, we have more problems. So what are some of the common operational challenges? Well, first one is bootstrapping. So now I want to use Docker, but or Kubernetes. How do I even get it up and running in the first place? How do I get the whole platform up so I can start doing fancy things like scheduling, replicating my containers, and getting all the benefits that I get from a container orchestration platform? And then provisioning and configuration. How do I add more resources? Which container runtime do I use? Docker? Well, how does Docker even get installed in the first place so that I can start running Docker? And what OS images do I use? So all these are kind of at the low level provisioning configuration concerns that we all starting to have to worry about. And then obviously managing updates. Well, how do I upgrade the platform itself? So I know that, okay, I can do rolling updates of my application with the Docker Swarm or Kubernetes, but what happens when I actually want to upgrade the platform itself? When I want to upgrade the OS, apply patches, how do I go about doing that? So there are a lot of great tools out there today that are available to solve these problems. For example, Terraform, I'm sure many of you are familiar with, is a great tool for declaratively specify your infrastructure, as are other tools such as Ansible, Chef. CloudFormation is a pretty common one. AWS has a nice way of letting you script together all the resources that needs to be provisioned in order to create your Docker Swarm or your Kubernetes cluster. And plus, there are many other great open source projects that are out there now, such as Kops, Kubicorn, Bosch, or you may decide to roll it your own by writing your own shell scripts. So there are a lot of tools out there that actually allowed us to to do the sort of things, bootstrapping, provisioning, configuration, and managing updates. But as we talked about earlier, and as you have seen through Laura's presentation, well, there's a lot more to it now. We got the issues around how do I maintain the quorum? How do I manage them? What happens when the quorum blows up? How do I recover? Well, better yet, how do I even prevent it from blowing up in the first place? And so that's the problem of resiliency. How do I ensure my platform is actually highly available so that my applications are as well? And then there's the problem of scaling. Well, you see that I may start out with a cluster of 10 nodes. Well, what happens when I actually run out of resources to run my tasks? Now, how do I adjust the resource usage according to the actual demand? Do I always over-provision and have a bunch of servers and have them sitting around and everything's running low CPU utilization just so I can not have to worry about this type of things? Or do I have a way to kind of do a lot of things manually to make sure that I'm always on top of what my cluster is doing? And then finally, it's cost. Well, now I've got this big cluster. Maybe I'm only using them at 50% of the time. Well, is there a way for me to better improve my costs so that I actually don't have to pay for a large cluster? So now that we actually have this huge construct, the problem that I have presented now is, well, there are actually a lot more things that we need to think about. So we have this environment called a container orchestrator that actually runs things, if you will, virtually now. But let's talk about the construct itself. So let's talk about InfraKit. So what exactly is InfraKit? InfraKit is actually a pretty new project that's launched open source by Docker a little bit less than a year ago. And it's really meant to try to address a lot of these issues. So at its heart, it's a toolkit for infrastructure automation. So what do? We provide a lot of tools and functionalities for provisioning, management, and self-healing, most importantly, for higher level systems. And the toolkit itself focuses on patterns and automation. So again, like everything else, similar to what you normally have seen with tools like Terraform or CloudFormation, we focus on convergence of the infrastructure to a declarative specification. But we also start incorporating other commonly found patterns, such as scaling groups, how to do rolling updates, and we'll also provide infrastructure for exposing metadata of the information about your cluster, as well as the events that are happening within the cluster. And the focus is on immutable infrastructure, meaning that we are, I'll get into that in a little bit. But what exactly is it though? I mean, like we talked about this at a pretty high level, but what are the bits that I actually get? Well, it's really a set of building blocks for the control plane. So InfraKit itself is a set of controllers and plugins that you can actually deploy, either as containers, pods, or bare daemons on the host to actually enforce that infrastructure state. And it also provides the tool for you to actually automate a lot of processes, such as scaling, updates, because it comes with a CLI that allows you to interact with these remote server objects. So it's a tool for you to embed into your own cluster environment. And one of the typical use cases in an application area where we at Docker have found for InfraKit is that InfraKit is now embedded into some of the products, such as Docker for AWS and Docker for GCP. So the idea is to embed these components to make the cluster itself self-healing. In addition to the CLI, InfraKit also has a templating engine for processing configurations. So it provides a certain level of flexibility in case you had to deal with different types of configuration formats. And overall, the entire project is written in Go with API for server components and really hooks for you to extend and build your own complex infrastructure orchestration systems, which I'll get into a little bit. So where does it fit? So logically, you can think about this, is that maybe for those who are familiar, you use Docker or the kubectl, tools to actually run your applications. And typically, depending on the environment that you're in, you're either using the cloud providers, CLI, such as AWS, AZ, or G-Cloud. And InfraKit is sort of the equivalent of that. It's that layer beneath. And architecturally, how InfraKit actually fits with the rest of the stack is that it sort of sits in between the runtime, the orchestration system, and the actual infrastructure itself. So it actually exposes, it's not only able to provide the services of say, emulating like a auto-scaling group, but it also offers that as an API to the higher level system. And I'll get into that in a little bit. So the entire system is really composed of multiple objects. And there are different types of objects within InfraKit. So on the server side, there are controllers and there are plugins. And on the client side, there's obviously the API that you work with, and the command lines, InfraKit as a CLI, and the templating engine and functions. So let's get into the plugins. So within InfraKit, there are this concept of plugins, and plugins are actually expose a number of different APIs for different purposes. So there's the instance interface, which basically offers CRUD operations on resources. Flavor is sort of in a, if you will, it's a service that injects application-specific modifications of a resource configuration during provisioning or termination. So, for example, in the case of a swarm flavor, it's able to inject the swarm join tokens at the time when the node comes up, and it's able to inject additional instructions such as draining, doing a swarm drain to drain the jobs on that particular node, or similarly for the Kubernetes, in the Kubernetes flavor, one of the things that it does is it inject the QADM joint token. And there's also a metadata interface. The metadata interface actually allows a plugin to expose system-level interface information in a path, in the file system-like manner. And then finally also expose streams of events through the events API. And then we have controllers. So controllers are really layered on top of plugins. So the controllers are essentially running control loops that enforce the desired state. So anything from the size of the cluster, the image of the instances that you're running, a number of other things, and the changes are actually detected via the actual fingerprints of the configurations that you submit to it. And there are different kinds of controllers that are available. A group controller is essentially a controller that ensures a collection of X entities actually exists at all times. The enrollment controller is to make sure that all members of a particular group must also be in another group, in some other Y group. And ingress is a controller that essentially is sort of a specialization of enrollment, if you think about it, is that it makes sure that traffic from X also goes to the members of a different one, Y. So think of it in terms of the effect of adding the backend servers. When you spin up a new host, adding that backend server to a backend pool for a load balancer is one instance of using ingress and enrollment. So let me kind of go into just kind of give you an idea of what that looks like. So I started up a cluster on AWS just to see here. So there's a cluster of Docker Swarm. There's a Docker Swarm cluster running on AWS right now. And that one is actually managed and powered by InfraKit. So when you connect to it using the InfraKit CLI, you'll see that there are a set of all the different managed objects that are available to you. So in this particular case, we see that there's a flavor. It's running the flavor manager and worker. So this is a Docker swarm. There are some groups available. So a good way to check it out is to see what's my declarative configuration for this cluster. When I see that I've got a couple groups here. One of them is a swarm manager group running on these IP addresses. And these are the ones that are forming a quorum. And obviously, this is how these are configured in terms of AWS instance and where they're running. And then the second group of a set of workers with a size. So this is fine. So in order to, so with InfraKit, what you see now is you can actually manipulate the cluster at will. So I see that in this case, my workers are actually 3 nodes. So let's see. Let's scale up. Oops. So you see that, now that we see that there actually nodes are coming up, and let's go do this. We already see that some nodes are starting to join. So 1, 2, 3, 4, 5. So now all these new nodes just come up and join the swarm. So you can use the InfraKit as a CLI to easily scale up and down. But what's actually more interesting is kind of going into the scenario that Laura was talking about earlier. Maybe we should just start try to trash a manager and see the system self-recover. So fingers crossed. Because the whole point of InfraKit is that InfraKit actually now is embedded into the swarm itself. It gives the swarm itself the self-healing ability so that it leverages the swarm in terms of leader election to actually run in high availability mode. At any given time, as long as there's a quorum, as long as your swarm is functioning, it's able to detect the changes within the group and proactively spin up a node when a manager crashes. So that's, for example, let's try to do this here now. I'm gonna kill, I don't know, this one. Instance state. So, do I want to terminate? Yes. So one of these guys will start to disappear. Oh, so now I see that manager just become unreachable. And what's actually interesting about this is so now that the swarm has detected that the manager is actually down. A couple of notes is that you can say, well, that's interesting. Well, why don't I just run an auto scaling group? The problem with auto scaling group is that there's really the notion of identity. All the nodes are, kind of the same. But the problem with swarm quorum itself is that the nodes actually have identity. So one of the key things that we actually try to do with InfraKit is to take care of some of those things in terms of managing the state. So in the earlier presentation, you heard that the var libdocker swarm folder. Well, that turns out, so now we're bringing up a new node right there. The manager is coming up. And after a while, it's going to rejoin. So the thing that's different about this is that instead of using auto-scaling group, we're using InfraKit because InfraKit actually respects and understands the fact that you need to preserve the state of the RAF quorum. So instead of just doing what an auto-scaling group will do, which is just simply spinning up a new node, which as far as the quorum is concerned, it doesn't really know if that DAO manager may come back. So as far as when it actually sees a new node coming, it actually thinks a new member has just tried to join the quorum. Oh, we're back. So, and notice that as far as the quorum is concerned, it really looked like a temporary network partition. It joins the quorum. The new node basically got brought up by InfraKit, reattached to disk, has all the swarm quorum state. It represents itself as the old manager. So the entire quorum continued going without skipping a beat. There's no more things like, oh, I need to go back and demote a node, remove the node, rejoin the quorum, none of that, because InfraKit actually manages this entire process. It makes sure that your entire quorum is actually up and running. So that's sort of the auto-scaling group functionality provided by InfraKit. And there are also a couple other things that InfraKit exposes to you. Remember I said earlier, there are different kinds of interfaces. So for example here's a managed object called flavor swarm, and it's a swarm manager. It also implements a metadata interface. What does that mean? That means it also exposes certain information that's available in the path-like format. So in this case, that particular managed object exposes a set of information that you can actually look at using through the CLI very simply. So for example, I may want to know what's the actual join token for the swarm itself. And this becomes a very simple way to actually query and interact with information that's in your cluster. So it's, in a sense, it's like a sysfs for your entire cluster. You can also see events that are coming out from the cluster. So we do have a, let's see, a timer. This just kind of for show. Oops. So now I can tail oops. So now, you can build new plugins that are essentially emitting information coming out of the cluster itself, and you can use InfraKit as a way to visualize the event stream. So that kind of gives you a basic idea of some of the bits and pieces that are in InfraKit. And continuing on, the big thing about InfraKit is to focus on composition and layering. So this is actually, because everything has well-defined RPC interfaces, we actually allow you to compose different kinds of, embed different objects within the JSON configuration or YAML configuration so that you can actually create new functionality. So the example that I showed you a little bit earlier is to build an auto-scaling group. So in this case here, you see that we're combining two pieces. We're combining the instance plugin, and we're combining a flavor that, in the case of Kubernetes or Swarm. So what it does is it injects a configuration specific to the application, and in this case, we're using, say, Terraform, for example, to actually be the execution to provision things. So now, moving on, I can actually make it so that, well, that's kind of compose and build new things out of that. Let's use a selector plugin. A selector plugin itself implements the same interface as instance, but what it does is it allows you to compose into two different multiple instance groups. So now you can actually start doing fun things like, well, let's provision across zones, or maybe a provision across clouds. In this particular example here, maybe we say 80% will go to AWS US East, and 20% goes to GCP US Central. Again, this is just allow you to actually control how you want to create new nodes on the fly, on the fly. But at the same time, you're still maintaining a constant fixed group RPC so that your application, such as a cluster autoscaler or your CLI, is basically using. So when you just say scale to 10, it's most likely going to end up doing 80%. It's going to put 8 new nodes in AWS East and 2 nodes in GCP US Central. Or we can do provisioning priorities. Just compose it into another tier selector that actually supports the notion of picking one by one and try to provision. So this actually enables us to do some fun things like, well, let's have an auto-scaling group that first will try to provision instances out of my on-premise vSphere setup, so that I'm building my own using my own vSphere VMs that I already pay for. But if I can't, try to do an AWS Spot instance because it's cheap. Well, if I still can't, well, I'm going to pay more and use the actual on-demand instance. So this is the kind of strategy InfraKit actually allows you to do. And you do this at the level without writing code, but simply compose a new YAML file or JSON file as the configuration that you want for the cluster. So in conclusion, InfraKit as a project tries to implement a lot of common controller patterns to create a toolkit for allowing you to build complex infrastructure automation and actually embed that into your cluster. So this is the motivation for this is when we build products like Docker for AWS, Docker for GCP. We want the cluster, the Swarm, not only be easy to use as a container orchestrator, but also self-heal, as I have shown you earlier. And then layering and composition of this kind of design philosophy actually lets you use either a little bit or a lot of it. You can do a one-shot provisioning tool, kind of like a Terraform. You use it, and no big deal. Or you're probably better off using whatever tool that you like. But what's nice is you can start layering other functionality. So now you can start to maybe bootstrap the entire cluster, or now even do some of the more complex use cases to make your entire cluster elastic. Let it make it scale automatically, maybe hooking it up to a Kubernetes cluster autoscaler, or maybe hook it up to Prometheus to preemptively scale out your cluster. So really, our goal is to build a set of toolkits for you to build out this kind of really complex infrastructure orchestration systems. And with that, for those of you who are interested, come check out InfraKit, and this is where you can find us. And that's it. Thank you for your time.